Okay, hello. I'm Brad Kemp. I'm the president of Beechwoods Software. We're a small software services and integration company focusing on embedded Linux, embedded Android, embedded tiny devices. I'm also the chair of the location group within the AllJoyn Alliance. And so I'm here today to talk about location services and what it is and how it works. So first thing I'm talking about is dumb decisions. Every day I make dumb decisions. Now these are not stupid decisions or ignorant decisions. They're just dumb. I walk in the room, I turn on a light bulb. I walk out, I turn it off. Really dumb. Now I'm really good at the first one, but not so much at the second one. So I tried to make it better, and I got motion sensors. Now motion sensors are wonderful things. You move, they do something. They turn the lights on. Nothing happens, they turn it off. If my heat was on motion sensors and I sat quietly in the corner reading, I would get cold. We've all seen Cubeland, right? Working after hours typing, lights go out, work, and you know, it's really frustrating until some bright individual gets a good idea and puts a fan there with some ribbons. Problem solved. The ribbons are floating, motion sensors see motion. It's all well and good until the last person out doesn't turn the fan off, obliterating the entire reason for the motion sensors. We have IoT, and with IoT, I can make my lights go on and off from anywhere. I can do it from here. And if I remember that I forgot to turn off my lights, I could turn them off now. What it's given me is really a 2,500-mile finger, which is cool, but not good enough. What we really need to do is track the people. Because once you start tracking the people, you can do some really intelligent things with all your devices. You can make sure that the environment the person is in is what they want. You can get some information about where the traffic is of people. The number of possible scenarios, if you know where the people are in your IoT environment, it makes it such a much richer experience. Now, there's a lot of solutions out there right now that do that. There's a lot of ways we can track. We can track people based on beacons. We can track people based on Wi-Fi, or at least devices. We can do some video recognition. There's some sonar. There's some kind of strange, I've heard about this geomagnetic one. I'm not quite sure how that one works. But what I do know is that there's a lot of ways to do it. There's a lot of interesting technology today. Unfortunately, if you're an app writer, you have to know all about all those different ones. You have to know how the Wi-Fi one works, how the Bluetooth one works, how the Zigbee one works, and what that API is. So what we've done is we've come up with, within the AllJoyn Alliance, is a method of abstracting the location information that the app builder wants from the data collection that's necessary to know where people are. Now, for the purposes of this discussion, I'm going to talk about Bluetooth and beacons, because that's what we work with. But everything I talk about is applicable to any kind of technology. Come on. So first I want to talk about a couple of definitions for this work. First is location services. And what location services is a repository that sits somewhere in your network where all this information resides. It's nothing more than an elaborate database. The two important things are the contributing devices. Contributing devices are either sensors or phones or complete location service systems. And what they do is they feed different information into the location services so that applications can then use that to do smart things. The thing we track is called an entity. We call it that because it really is a device, but we don't really know much about it. An entity is in our world, is nothing more than a human readable string and a device ID, which is a globally unique thing, either a UUID from Bluetooth or a MAC address from Wi-Fi, or whatever it is that you have that makes that thing unique. Hey. Okay. So part of the reason we want to do this is A, it's a database, but B, it does do the abstraction we need. It's a common interface for applications. The application writers can write one application and access a wide range of services. And the people who have location solutions don't have to convince the entire applications community to write to their APIs. So we've broken down location services into 5 subservices. One is presence. Are you there? It's important. So we can tell you whether or not the entity is present or absent. The next is distance, which is the distance between 2 entities. Now, depending upon how the information is contributed, we may not know all the distance pairs, but we may. The third is a geofence. It's simply a sphere around an entity. You know, is my teenage son close to the refrigerator? Oh yes, I have to go get more food. Again, position is where is somebody? It's either in the absolute WGS 84 coordinate GPS system or in an origin XYZ, which is very popular for location services within buildings. To know that someone is in this quadrant of the store is very, very important. And finally, containment. Are you in a room? Are you in the plaza? It's much more of a condensed presence. But even though you and I are 10 feet away, if there's a wall there, we're in 2 different containers, and it makes no sense to try and do operations between 2 entities that have a barrier between them. So here's a little show and tell of how it works. The entity moves, and each of the contributing devices sees that movement and feeds location services. And then apps can use that information to do cool things. It's really not that complicated, but there are some pieces that are interesting. In terms of how to use location services, the one thing we work with is filters. And each of those subsystems have a slightly different filter, but the basic gist is it's an array of entities that can be wildcarded so that you can find the entities you care about. Now, let's say you're like, I don't know, like me, and you've got 3 radios on you. I have a phone, and a watch, and maybe a Fitbit and a tile, so that's 5. Because of the way we've done entities, they could all be named Brad. There's 5 different entities named Brad. So my application could just look for Brad, and then when it gets the information on 1 or 2 of them, it could decide what to do. So that would be Brad star for all the entities, all the Brad entities out there. Or if you've got, if you're giving out beacons, they've got a UUID that's yours. And so you could just look for your UUIDs. So we've allowed some great flexibility, and the obvious one is star star, which is give me all the beacons. Not a problem. Give me all the entities. Now, each filter does have service-specific information. For instance, distance. You need a reference entity to know who you want to be near. There's some other things, like distance may have a feet or meters, how many meters I care about. I don't care if with a resolution less than a meter or 2. But by and large, it really is filters that we work with. And what we use these filters for are 2 simple things. One is query. Hey, here's the filter. Tell me about all the entities. Distance, presence, containment, what have you. And the other one, which is a little more interesting, is subscribe. And with that, it's a subscription to the service. And what it tells the service is that anytime any of the entities that match the filter changes, I want to know. And what a subscription does is it creates the tracker. The tracker is a bus object. So the AllJoyn, if you're not familiar with the AllJoyn bus, I could tell you all about it, but I don't have that much time. But as a bus object, it may or may not be, you may not have exclusive access to it. So what this object will do, it will be signaled when there's a change in the entity that matches your filter description. Your application will get a signal, and it will pass back the actual entity that changed. So if you have the wildcard star star, you're not going to get a signal and have to go iterate through all of the entities that you got the first time to figure out which one it is. You get to know what it is. The tracker also contains a couple of useful things. One is the filter that you use to create it, which is always good. The other is a method to retrieve all the entities that match that filter. So if you want to see just to get a refresh on what everything is, you can. We did not specify an unsubscribe because this is a bus object, so we may not be the only people that are using it. So each tracker has a timeout, and it's an application-specific timeout. It will self-destruct after X seconds. There's also a threshold that before the timeout, It will notify, all the trackers will be notified, all the listeners to the tracker will be notified that it's about to expire, and they have the ability to keep that tracker alive. That way we don't have to worry about, messy garbage collection. They will go away, and we will not, once the network quiesces, we will not consume all our memory. So that's pretty much the application side. The way we get information is a contributing device, and a contributing device is either a sensor on the wall, and a phone. Phones are great contributing devices because they can hear all the beacons around and give location services where they are. It can also be a complete location subsystem. It really doesn't matter. But what it's doing, it's contributing the subsystem-specific information, whether the entity is present, how far away this entity is from another, where the entity is in an origin XYZ location. And in fact, contributing devices don't have to be devices. We actually have software that's contributing devices because we'll take distance data and turn it into location data. So it allows a wide variety of ways of injecting location information into the service to make it richer for the applications. The other thing contributing devices need to do is they need to sort of smooth data. iBeacon, which is probably the noisiest. Bluetooth is chatty just by nature, but iBeacon is absolutely the worst. It's a 100 millisecond cycle. And if you've got a lot of people moving and they're changing data, they're moving and the motion is detected every 100 milliseconds, you flood the bus. So the contributing device has to sort of smooth that out. It also has to take into account in the Bluetooth area, variations in the signal received. We're using the return signal strength indication to find out how far away people are. And it's not it's not a consistent thing. Different radios have different RSSI strengths that mean different distance values. So there's some training involved to get it right. But also, not only that, there's also positioning. For instance, what is a human being but a great big bag of water? And what does that do to signal strength? Well, it kind of gets in the way. So your contributing device actually is probably the hardest part of this whole system, in that getting accurate data is really the responsibility of the contributing device. Also of the beacon manufacturer. We need more good RF engineers, because if you wrap the antenna around the battery, you get crappy results. I have moved 40 meters in a millisecond. I should go to the Olympics. But I've also got the same chip from a different manufacturer, spot on, just absolutely perfect. So there's going to be a lot of variation, a lot of work for different contributing device makers, because it is still that RF black art. The other thing the contributing device do, besides the smoothing, is kind of the filtering, is what's the cadence do we want to update location services? We had the booth at CES, and I actually turned on our contributing device without any filters, without any smoothing, and our net lasted 3 seconds. It was just too much data. So that's the contributing device. And that's kind of all the components of location services. The one thing I do want to talk about is privacy. So we are using, AllJoyn comes with Security 2.0 and the ACLs, they're in there. We are using those ACLs to control access to each entity. So the entity controlled the access to each different applications using these. Interestingly enough, anonymous entities that are not registered, who don't have a well-known name, who are just found, have no privacy. We tell the world about anonymous entities. If you want to be anonymous, you need to register your entity and then mark it as private, which is not really anonymous, but as close as we can get. And again, the interfaces themselves are under the Security 2.0 stuff, so it is a secure interface, up to the AllJoyn level of it's an authenticated peer, etc. And it's presence. All right, so I'll go into each of the services a little bit deeper detail. The presence service provides information about whether an entity is present or not, or is detectable. And the algorithm is that as long as a contributing device detects it, the entity is present. When all the contributing devices say, oh, they're gone, then that entity is declared not present. It's pretty straightforward. Yeah, and obviously you can query for finding out, is John there? The geofence service. This is pretty much like the distance service, but it's basically builds a sphere around a specific entity and tells you whether or not another Boolean is the other entity inside or outside that geofence. It's useful for a lot of applications. You know, is someone coming on my property? A lot of different things need this kind of not very fine grain presence location, but greater than just are they there. We have the distance service, and the distance service is the distance between two entities. So when you query, when you create that filter, you need a reference entity that says, this is how many entities are close to this entity. Here's the distance. You also specify accuracy. And accuracy in location services is pretty strange. If you've ever built an Android app using their location services, you can do a call called getAccuracy. And it will return you an integer that is the number of meters that there's a 68% chance that you are within this location. And that's their version of accuracy. And that's GPS, because GPS is, 3 meters is best, and you can drive to Iceland, apparently, according to Google Maps, when it was trying to find me. So we're not always accurate, but you do as an application developer need to know how accurate you are. So we are providing what we believe is the accuracy, and each technology has a different accuracy, which is going to make it hard on the developers, but at least they can filter out things that they don't want. Again, not all entity pairs have distance information, because, again, it's the contributing device that's contributing that information, and unless there's a service that's doing some sort of algorithm to figure out what two non-contributing devices' distance are, you won't know. Now, those algorithms are public, they're available. Trilateration is what we've used. It does require knowing the location of each sensor to figure it out. You do have to have some fixed points in your environment to do the math to figure out where two entities that aren't telling you their distance is. But if everyone's using their phone, that's easy. You can find that out. Position service, it's pretty simple. It's where are you? It's either WGS84 data, which is where are you in relative to the core of the Earth in latitude, longitude, and altitude. Or it's origin XYZ, where an arbitrary origin is picked, and then your XYZ coordinates off there are reported. The origin XYZ is very popular in stores, very popular in buildings where you don't really know what your longitude and latitude are. It's too hard to calculate. People just don't want to deal. And so we're supporting both of those. And finally, the containment service. This provides information on whether a device, whether or not you're in a prescribed area. Now, honestly, the working group decided to punt on this because we tried to figure it out, and we figured out that if we figured this out, we would never get this project done in a timely manner. So we're releasing the first 4 services now, and then we'll go back and do containment, because there's a lot of just logistical problems with containment in terms of defining what a container is, never mind whether or not you're inside it. So don't look for containment service in the first release, but we will get there. Before I go on, I mean, is there any questions so far? Does this all make sense? Well, that's good. Quick talk. A couple of scenarios. There's a lot of scenarios, actually. Home automation, which is my favorite, because I'm really tired of finding that I've left the basement light on for 4 days. It really could help out a lot. It could help out a lot in terms of my house that beeps, because my house beeps. It beeps when the washing machine goes off, it beeps when the dishwasher goes off. Other beeps happen, and I have no idea what they were. It would be nice if the machines were smart enough to know I was in the room and beep, and if not, text me or do something else, please. Because when I hear a beep far away, I don't know what it is. But there's other things. We've found some interest in passenger tracking. Airports are starting to pick up this kind of technology because A, it's good for the consumer. I mean, finding a way to the gate is always lovely. But B, if they would know where Jane and Joe Doe are who are holding this plane up, and if they're still at the bar, just leave. But if they're running to the gate, maybe wait a minute, that would be nice. Convention management, just getting the demographics of the traffic flow. Again, you can, as an application, you can sit and just watch where all the devices are. And you can get some good ideas of what kind of flow you have and where there's too many people and where there's not enough, what a key spot is, what a key spot isn't. I mean, the list goes on and on. I'm sure that no matter how many scenarios I bring up, there's even cooler ones out there. So what I'm asking for is help. We're a small group. There's only really 4 of us who are really active, 2 academics and 2 industry. We hold a WebEx every Wednesday at 11 a.m. Eastern. We change it every time someone has a conflict because we're so small we can. And we're about to release the code to the All Student Alliance. It should show up probably a week from Friday. We are right now in the Interface Review Board has reviewed it, and we're responding to their comments. And once we get that done, we will push it all up again, and everyone can have at it and see if we can make it work. That's really all I had. It's not a long talk. Questions, answers? Guys, have a great time. That's my show.